So here we are presented with a very interesting problem, and we are supposed to find the value of x. Now, by looking at this, we could see that there are x's all over, and we would need to find the value of x. So what I'm going to actually do is to actually carry out the operation on each side separately. So as you can see here on the left hand side, we have x plus 5 over x plus 4, take away x plus 6 over x plus 5. So I'm going to actually do this side by side. So let me rewrite what we actually have. So x plus 5 over x plus 4 minus x plus 6 over x plus 5, and this is equal to x plus 7 over x plus 6 minus x plus 8 x plus 7. Okay, great. So now that we have that written down, what I'm going to actually do is to I'm going to draw the fraction bar for the common denominator, which would be x plus 4 being multiplied by x plus 5 on this side, and this would be equal to, now on this side it would be x plus 6 being multiplied by x plus 7. Okay, great. So let's carry out the operation, and we would be left with, well, here we would have x plus 4 would cancel. We would have x plus 5 all squared minus, let's use a big bracket for this side. And this is x plus 6 times x plus 4. So x plus 6, x plus 4. And on the right hand side, x plus 6 would cancel. We would have x plus 7 all squared. So x plus 7 all squared minus, and let's use our square brackets again. And this would leave x plus 8 times x plus 6. Okay, great. So now that we have everything, we could go ahead and expand our brackets, and x plus 5 all squared, that would leave us with x squared plus 10x plus 25. And let's leave the square bracket and let's expand what is here as well. So x plus 6 times x plus 4, that will be x squared plus 10x plus 24. And this is all over x plus 4, x plus 5. Okay, great. So now let's do the same on the right hand side. X plus 7 all squared, that would be x squared plus 14x plus 49. And this is, well, we're subtracting 8 plus x and x plus 6 from that. So let's expand that as well. We would get x squared plus 14x plus 48. And this is a square bracket. And this is all over x plus 6, x plus 7. Okay, great. So by looking at this, we could see that the negative sign would be distributed throughout this bracket. Let me indicate that. So the negative sign would be distributed throughout this bracket. And as you can see, only the constant is off by 1 in the bracket. So everything else would cancel, and we would be left with just 1 over x plus 4 times x plus 5, and this is equal to 1 over x plus 6 times x plus 7. Okay, great. So seeing that we have both numerators being the same and both sides are actually equal, so we could actually just flip this fraction. So basically whatever is on the top goes on the bottom, whatever is on the bottom goes on the top. It will be the same as if we were to cross multiply. So we would get x plus 4, x plus 5 being equal to x plus 6, x plus 7. Okay, great. So we could actually expand these brackets on both sides to find the value of x. So on the left hand side, we would have x squared plus 9x plus 20, and this is equal to x squared plus 13x plus 42. Okay, so seeing that we have both x squared terms just being multiplied by 1, those would cancel. So we would have actually have 9x minus 13x being equal to 42 minus 20. So negative 4x is equal to 22. So here we have x being equal to 22 over negative 4. That is simply negative 11 over 2. We could actually leave this as a fraction, or we could actually say this is negative 5.5. Now we're going to use it as a decimal because we want to actually prove that this is correct. We want to prove that our calculation is correct. So initially we had x plus 5 over x plus 4. And this is taking away x plus 6 over x plus 5. And this should be equal to x plus 7. Now you see why we left it as a decimal, because this would come in handy. So x plus 6, x plus 8 over x plus 7. Okay, so let's substitute the negative 5.5 throughout this equation and see what we get. So negative 5.5 plus 5, that is simply negative 0.5, and this is over negative 1.5. This is subtracting, so negative 5.5 plus 6, this is 0.5, and this is over negative 0.5. Now on the right hand side, we would have 1.5. So 1.5 would remain here, positive, and this would be 0.5 minus 2.5 over 1.5. Now let's see if these equate to the same thing. So here we would have 1 over 3. So 1 over 3 plus 1. Let's see if it is equal to 3 minus 5 over 3. Let's see if both sides are actually equal. So this is 3 over 3, so this is 4 over 3, and this is 9 over 3 minus 5 over 3, so this is actually 4 over 3. So indeed, negative 5.5 is the correct solution, and you could actually double check to see if there are any other solutions to this problem. So that is basically the answer to this problem and the solution to our question. So if you enjoy these videos, please be sure to leave a like and a comment down below. It would be much appreciated. Thank you for watching. If you've made it this far to the end, please leave a comment and comment the magic word apple. Thank you for watching. See you in the next video.